Wheatstone bridge is a very important topic from your second lesson, current electricity. 5 mark question. Applications of Kirchhoff law. This Wheatstone bridge topic is applications of Kirchhoff laws. An important application of Kirchhoff law is the Wheatstone bridge. It is used to compare resistances and also helps in determine the unknown resistance in electrical network. What is the uses of this Wheatstone bridge means? We have to determine the value of unknown resistance in the electrical network. So the bridge consists of 4 resistance P, Q, R and S connected and shown in the figure. A galvanometer G is connected between the points B and D. The battery is connected between the point A and C. The current through the galvanometer is represent IG and its resistance is capital G. Applying Kirchhoff current rule in junction B. Applying the Kirchhoff current rule to junction B. The equation is I1 minus Ig minus I3 is equal to 0. Equation can be written as I1 minus Ig minus I3 is equal to 0. I1 current entering to the junction. So what is the first law of Kirchhoff rule? Entering to the junction is taken as a positive, leaving from the junction taken as a negative. Here I1 current entering to the junction, that is why we can take positive I1 plus I1 minus Ig minus I3 is nothing but leaving from the junction. That is why we can take negative sign minus Ig minus I3. So total amount of current is equal to 0. I1 minus Ig minus I3 is equal to 0. The next step, applying the Kirchhoff current rule to junction D. This junction D. Here I2 current and Ig current enter into the junction. That is why I2 and I2 taken as Ig is taken as a positive. I4 current alone leaving from the junction. So this current taken as a negative. That means I4 current can be taken as negative. I2 and Ig is taken as positive. So the equation can be written as I2 plus Ig minus I4 is equal to 0. The next, we can apply Kirchhoff's second law. That means voltage rule or loop rule. So here closed circuit. In a closed, because second statement important condition is, second law of Kirchhoff rule, important condition is circuit should be closed. First, we have to take this circuit A, B, D, A. From this circuit, the equation can be written as I1P plus IgG minus I2R is equal to 0. Because the statement is product of the resistance and the current. Sum of the algebraic sum of the product of the resistance and the current. So that is why I1P plus IgG minus I2R is equal to 0. Why put this minus sign? Because clockwise direction is considered as a positive, anti-clockwise direction is considered as a negative. I1 and Ig is the clockwise direction. I2 is the opposite direction, that means anti-clockwise direction. There are 3 current flowing through this closed circuit, A, B and DA. So I1, Ig and I2 are the 3 current. I1 and Ig in the clockwise direction, that means positive direction. I2 alone in the negative direction. That is why the equation can be written as I1P, it is a positive. I1G also it is positive. But I2R is negative. So I1P plus IgG minus I2R is equal to 0. Then next closed circuit. Next closed circuit A, B, C, D, A. Totally 4 current. There are 4 current passing through the closed circuit I1, I3, I2, I4. But I1 and I3 is taken as positive because this is the positive direction or clockwise direction. But I2 and I4 is the anti-clockwise direction or opposite direction is taken as a negative. Equation can be written as I1P is taken as positive plus I3Q minus I4S minus I2R is equal to 0 because the statement of second rule, sum of the product of the resistance and current. Algebraic sum of the product of the resistance and current is equal to the algebraic sum of the EMF in the closed circuit. I1P plus I3Q minus I4S minus I2R is equal to 0. The next important point of the wheatstone bridge network, electrical network, when the point B and D are the same potential, B and D are the same potential means bridge should be balanced. As there is no potential difference between B and D, no current flows through galvanometer. There is no potential difference means current it does not move from B point to the D point or charges does not move from B to D. That is why there is no current flows through the galvanometer. Ig is equal to 0. That means galvanometer current is equal to 0 because circuit should be balanced. The next step is substituting this Ig value to the equation 1, 2 and 3. What happened? We get I1 is equal to I3 because Ig value is 0. So I1 is equal to I3. I2 is equal to I4 because Ig value is 0. I1P is equal to I2R because Ig value is 0. These value substituting the equation 2.49 here, substituting the equation 2.48, 2.49, 2.50, 2.51, substituting this equation 2.48. Then we will get I1P plus I1Q minus I2S minus I2R is equal to 0 because I3 can be written as I1. So that is why I1P, I1Q, here I3 can be written as I1. So I1P plus I1Q minus similarly I2S, here I2S, I4 can be written as I2, replaced as a I2, I4 replaced as the I2 minus I2R is equal to 0. Remove the common term. I1 is the common term. Remove from this equation. I1 is into P plus Q is equal to I2 into R plus S. The next step is dividing this equation. Dividing two equation. What are the equation? Dividing these two equation 2.51 and 2.52. These two equation dividing these two equation we obtain P plus Q divided by P is equal to R plus S divided by R. So the equation, simplify this equation we obtain I1 plus Q by P is equal to 1 plus S by R. Now 1 and 1 cancel each other. Q by P is equal to S by R. So reciprocal of this equation P by Q is equal to R by S. This is the bridge balance condition. Only under this condition galvanometer shows null deflection. Suppose we know the value of two adjustment resistances, the other two resistance can be compared. If the last point is very very important, if three of the resistance are known, P or S may be known means Q can be calculated. The value of unknown resistance, fourth one can be determined. So if suppose known, if three of the resistance are known, the value of unknown resistance, fourth fourth one can be determined. Thank you.